Hello everyone, it's a pleasure meeting you all in my mathematics class. I am continuing with my discussions and problems on convergence and divergence. Let me take, in order to make you well equipped with finding whether given series is convergence or divergence, certain tests are applied and how the tests are applied and what is the theory behind the tests. Those things I would like to discuss. So to give a start, let me take up this particular, start with this geometric series and test whether this geometric series is convergent or divergent and under what conditions it becomes a divergent or a convergent series. Okay. Now, I will take, this is a geometric series. See, a geometric series is given by, see, let me write this as S is equal to A plus AR plus AR square plus dot dot dot. It goes at AR to the power of n minus 1 plus dot 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 up to infinity. If, let us suppose that this is an infinite series, this is where this R is called the common ratio. R is the common ratio. What is this means? You must know that any term divided by the preceding term will be always R. That is, this is a geometric series because you see that AR divided by A is equal to R. AR squared divided by AR is equal to R. Like that, you find that this R is a common ratio. That is, every term is multiplied. Every term you find that it is the multiplication of the previous term by R. Or if a term is divided, if any term is divided by the preceding term. If any term is divided by the preceding term, immediate precedence, preceding term, the ratio is equal to R. That is, you will get R, which is nothing but called the common ratio. That is, every term is a multiplication by R of the previous terms. This is what is geometric series. And you see that what we are going to discuss is when this geometric series is convergent and when it becomes a divergent series. Okay. Now, so this is a geometric series. Let me write see what is this? This is the geometric series up to infinity. So let Sn be the sum of the first n terms, that is A plus AR plus AR squared dot 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 AR to the power of n minus 1. You must know that when we put n is equal to 1 means R to the power of 0 you get first term. When you go to 1, when you go 2, you get the second term. So this is up to nth term. Okay. Now, let me call this as your 1. And 1 into R gives you R into Sn. This is equal to AR plus AR squared plus AR cubed dot 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 up to AR to the power of n. Because you see that when this is multiplied by R, you get AR to the power of n. Now call this as your 2. Call this as your 2. 1 minus 2 gives you Sn minus R Sn, which is equal to, you must know that this R, this AR will go off, this will go off, this will go off. So like that it goes on AR to the power of n minus 1. Here you see the preceding term here is AR to the power of n minus 1. They will get cancelled, leaving you with this A, and this is minus AR to the power of n. So this will become minus. So you get A minus AR to the power of n. That is, so this is equal to, this implies Sn into 1 minus r is equal to a into 1 minus r to the power of n. This implies that Sn is equal to a into 1 minus r to the power of n divided by 1 minus r. So this is what you get here. Now you see that here we have to make some discussion on this. See, if r is, see, if r modulus of, here we take this because we are taking this modulus r means the absolute value of r we are taking. If modulus r is less than 1, if modulus of r is less than 1, you see that when r to the power of n, when here, then r to the power of n as n tends to infinity will be 0. Will be 0, almost tending to 0. I will be tending, see, when r to the power of n will tend to 0. In which case what happens is that therefore Sn of limit n tending to infinity will be equal to a by 1 minus r. So as n tends, so this is the sum of the series, sum of the geometric series when it tends. So what is the sum of the series here? The sum of the series is nothing but a by 1 minus r, and therefore when r is less than 1, this is a convergent series. So this implies that when r is less than 1, the geometric series is convergent. So it becomes a convergent series if r is less than 1, modulus of r is less than 1. What will happen if r is greater than 1? If r is greater than 1, what happens is that it becomes an infinite series. That is r to the power of n. When r becomes large and n becomes large and large, you see that r to the power of n tends to infinity. That is the second, this is my first case. See, case 1. This is my case 1. So the case 1 is when r is less than, modulus of r is less than 1. You see that this geometric series will tend to a finite limit a by 1 minus r, and therefore it is a convergent series. Now let us discuss what will happen if r is greater than 1. So when r is greater than 1, what will happen? So if r is, case 2, r is greater than 1. So you see that if modulus of r is greater than 1, then what happens is that this n, so when it is greater than 1, then this r to the power of n will tend to infinity as n tends to infinity. Will tend to infinity as n tends to infinity, and that because of this, when r tends to, therefore Sn will tend to infinity. When Sn will tend to, that is Sn becomes a divergent series. That is when n tends to infinity, Rn tends to, when n tends to infinity, Rn tends to infinity. Hence the series Sn is a divergent series. Therefore S is yes, I call this my S. See, this is my 1. So 1 is a, so when r is, modulus of r is greater than 1, Rn tends to infinity as n tends to infinity. Therefore this S tends to infinity, and therefore this series, that is sigma of 1 to infinity of this a r to the power of n minus 1 is a divergent series. So this is the discussion. So when modulus of it is greater than 1, you see that this will become enormously large. What happens is that if it is greater than 1, r to the power of n will be tending to infinity, because of which you see that the whole series becomes it is not tending to a finite limit. Hence this is a divergent series. So when modulus of r is greater than 1, it is divergent. When it is less than 1, you see that it is a convergence series. We will discuss the case when R is equal to what? When R is equal to, see, case 3. When R is equal to, what will happen if R is equal to 1? So if R is equal to 1, you see that your S will be equal to sigma of 1 to infinity of A. That means you see that it is A plus A plus A dot dot dot, it tends to up to infinity. That means there is no limit for this. So this in turn implies that, so when this says that this sigma of 1 to infinity of A is a divergent series. I will put it like this A r to the power of, see, A r to the power of n minus 1 is a divergent series if r is equal to 1. So when r is equal to 1, it is divergent. When r is greater than 1 also, it is divergent. So when r is equal to, so sigma of 1 to infinity of A r to the power of n minus 1 is convergent for modulus of r less than 1 and divergent for n is for modulus of r greater than or equal to 1. So you see that this particular series is a convergent when modulus of r less than 1 and divergent when modulus of r greater. So this is the small discussion we can have on this geometric series. And let me take one more, what is called my P series. P series is like this. So this is called our P series. We can make a discussion because we normally apply this P series theorem to discuss whether given series is divergent or convergent. So you see that here you take this S to be equal to, see, it is 1 to infinity of 1 by n to the power of P. Now you see that this 1 by n to the power of P, this depends on whether convergence or the divergence of this series depends on what is the value of P that we are taking. Now let us suppose that if P, let case 1, let P be equal to, let us take it to be, P is equal to 1. P is equal to 1. So if P is equal to 1, what happens is that your series S is equal to 1 to infinity of 1 by n. This is 1 by n. Now we can use the integral theorem to prove to understand what will happen to this S, which is 1 to infinity of 1 by n. So let us apply the integral theorem. Now 1 to, see, we will take this S be equal to your 1 to infinity of 1 by x into dx, that is equal to limit of u tending to infinity of 1 to u into 1 by x into dx. So this is nothing but log x. This is log x and this is 1 to u, and u tending to, see, limit of u tending to infinity of this one you are having. So this is nothing but what? This is limit of u tending to infinity of, it is log of u minus log of 1, but log of 1 is 0, so log of, this is limit of u tending to infinity of log of u, this is log 1 is 0. So you see that when this is 0, this becomes infinity, and since this becomes infinity for n is equal to p is equal to 1, so this implies for P is equal to 1, the series, the P series, sigma of 1 to infinity 1 by n to the power of P diverges. So it diverges. Now, let us take now P is less than, if we take P is equal to 1, let us discuss what will happen if P is equal to 0. Let us discuss what will happen if P is equal to 0. So case 2 is what will happen if P is equal to 0. So here let us take case 2. Case 2 is P is equal to 0. So when P is equal to 0, your S will be equal to 1 to infinity of 1 by, it is n to the power of 0. N to the power of 0 is 1, so this is 1 to infinity 1, that is 1 plus 1 plus 1. It goes on infinity. This implies that S is equal to sigma of 1 by n to the power of P 1 to infinity diverges if P is equal to 0. So what will happen here? This 1 plus 1 plus 1 plus, it goes up to infinity. So in this case also, when P is equal to 0, you see that this series becomes, this series, P series becomes a divergent series. So this diverges. See, this diverges. Now case 3. P is less than, see, less than 1. Less than 1 means, you see that if it is less than 1, then you see that if it is less than 1, then it is, say P is less than 1 means S will be equal to what? S will be equal to, it will be equal to your, sigma of 1 to infinity, it is 1 by n to the power of P. What will happen to this n to the power of P if it is less than 1? If it is less than 1, you get this to be what? N to the power of, see, the value of this will be decreasing, but when the value of the denominator decreases, the value of the fraction increases. So this will tend to infinity. So this will tend to infinity. The sum will tend to infinity if the value of this P is less than 1. Can you understand? See, what I mean is that if P becomes less than 1, if P is less than 1, then you see that the value of this will be diminishing, in which case you see that the value of the fraction will be increasing. So it becomes an increasing series in the sense that it will be increasing and increasing, that it will be tending towards, it will be tending, that is, it is infinite, tends towards infinity, and there is no finite limit, and hence in this case also it diverges. So I will repeat this. When S is equal to this, when P is less than 1. See, less than 1 means, try to understand that it can be, I have discussed about 0 and I have discussed about 1. But if it is less than 1 means it can be a fraction or it can be a minus number. In all, if it is minus, then it will come to the end to the power of minus P. See, if it is minus, if you take this P is equal to a minus quantity, then you see that 1 by, see, it will be like this. 1 by n to the power of minus P, n to the power of minus P, which is equal to n to the power of P. So n to the power of P is a divergent, because as the value of P increases, it becomes a divergent series. Can you understand what I am telling you? See, what I mean is that if P is, see, suppose P is less than 0, then you see that 1 by n to the power of P, P is negative means, suppose this is minus P means, it will be n to the power of P. So in which case what happens is this number will be completely increasing. This will be tending to infinity as n tends to infinity. In which case this becomes a divergent series. And here what happens is that here this P is less than, if it is a small number, a fraction like then what happens is that the denominator will be decreasing, in which case the fraction will be increasing, that it will be tending towards infinity. Therefore, in which case if p is less than 1, if p is less than 1, sigma of 1 to infinity of 1 by n to the power of p diverges. So, in which case this also. So, when x is equal to 1, when p is equal to 1, it diverges. When p is equal to 0, it diverges. When p is less than 1, also it diverges. Let us see what happens to it when p increases. Okay. Now, let us see what happens to that. So, when p is greater than 1, see when p is greater than 1, see case as b equal to integral of 1 to u, limit of u tending to infinity of 1 by n to the power of p into x to the power of p into dx. So this is nothing but, so this is limit of u tending to infinity of 1 by u, it is x to the power of minus p into dx. That is x to the power of minus p plus 1 divided by minus p plus 1, limit of u tending to infinity of, it is 1 to u. So this is nothing but u to the power of 1 minus p minus, if you put 1 means it will be, if you put u is equal to, see, x is equal to 1 means this is 1, that is 1 by 1 minus, it is 1 minus p. Now you see that here, so we are getting this result. Now what will happen if, see, if 0 is, see, if 0 less than p less than p less than 1, if p lies between 0 and 1, then 1 minus p is greater than 0. So can you see this? If 0 less than, if you take p lying between 0 and 1, this 1 minus p is greater than 0. Therefore, if it is greater than 0 means 1 minus p is greater than 0. Therefore, u to the power of 1 minus p tends to infinity as p as u tends to infinity. See, as u tends to infinity. Now here you see that u tending to infinity, and because this tends to infinity, the 0 minus this will again be, it will be tending to infinity. Therefore, for, see, 1 minus p greater than 0, that is, which implies 1 is greater than p or p is less than 1. Therefore, for p less than 1, the series, see, this convergence is divergent. This when this integral when this that integral is divergent, then the series here, this will also be divergent. If this is convergent, this will also be convergent. But I have shown you that this particular integral for the value of p less than 1 diverges. For p less than 1 diverges. Therefore, sigma of 1 to infinity of 1 by n to the power of p diverges for p less than 1. Can you catch this? So you see that I am making a discussion on this, whether p greater, see, for p greater than 1, I am going to discuss for p greater than 1. But if you take p greater than 1, then I write it as 1 by x to the power of p, which on simple integration gives this, and we allow this u to tend to infinity. If you allow this u to tend to infinity, you get this. Let us suppose that your 0 p lies between 0 and 1. If it is so, you see that 1 minus p will be greater than 0. So if 1 minus p is greater than 0 means this part becomes 0. Now this tends to infinity depending on the value of this. Therefore, if u to the power of 1 minus p tends to infinity, the whole value tends to infinity. Because of which I can say that this particular integral is tending to is divergent. It is divergent. If this is divergent, naturally this will also be divergent. So this I am proving this whether this is divergent or convergent by considering the equivalent integral. So this is my equivalent integral. I make a discussion on this. So you see that this becomes if this is divergent, this is also divergent. But for 0 less than p less than 1, you see that for this this particular integral becomes divergent, because of which I can say that 1 by n to the power of p diverges for p less than 1. Now what will happen if p is greater than 1? See what will happen if p is greater than 1. If p is greater than 1, if p is greater than, see if this 1 minus p is greater than 0, see if 1 minus p is less than 0, this p is greater than 1. If p is greater than 1 means, what will happen if p is greater than 1? So if p is greater than 1, if p is greater than 1, what will happen to this? If p is greater than 1, it is, you get this to be, see, it is u to the power of 1 minus p. If p is greater than 1 means, you see that this is going to be, that is, it will be like this, u to the power of 1 minus p. So this will be 1 by u something like this, u to the power of t something like this. So 1 minus p, because p is greater than this, that you will get it as 1 by, it will be like this, p minus 1. 1 by p minus 1. So what will happen is that this will be going on decreasing, that this will become this will tending to a finite limit. When this tends to a finite limit, this will also, because this is a constant, because this is not going to affect this. So only we are depending on this, only we can make a discussion whether it is convergent or divergent. So you see that this 1 minus p for p greater than 1, for p greater than 1 here, for p greater than 1, this u to the power of 1 minus p, I'll write it here. See, u to the power of 1 minus p will be equal to 1 by, it will be, see this is, it will become as u to the power of p minus 1. It will become u to the power of p minus 1. As p increases, you see that the value of this will be decreasing and decreasing, that this remains the same. So you see that ultimately this approaches 0 very fast, that this will be tending to a limit. So you see that finite limit, because of which I say that when p is greater than 1, this tends, that is, when p is greater than 1, this integral of 1 to infinity of 1 by x to the power of p dx converges. Therefore, sigma of 1 to infinity 1 by n to the power of p converges. So I will make a small discussion on this. So if you take p greater than 1, then I will write it as 1 by. So I am going to use the integral theorem in order to discuss this part, whether this is a convergent or a divergent series. When this is so, I take this u tending to infinity of 1 to u, 1 by x to the power of p we are taking it to be greater than 1. Now you see that when n tends to infinity, this is a small integration. I do this disintegration. Now it all depends on whether this tends to a finite limit, and here the definite finite tending to finite limit depends only on this factor and not this. Don't bother about that. Now u to the power of 1 minus p. Now let us discuss the case when what will happen if p is lying between 0 and 1. If it is lying between 0 and 1, it automatically implies that 1 minus p is greater than 0. That means this 1 minus p will be greater than 0, means this will be always an increasing number. Can you understand? Because of which this becomes a divergent. Because of this, it does not tend to a finite limit, it tends to infinity. So the whole term becomes tends to infinity, because of which I can say that this is a divergent. This integral is a divergent one, and hence this is also a divergent series. Okay. So for p less than 1, it is definitely between 0 and 1 you can take. Between less than 1, you see that this integral is divergent, and hence this is also divergent. If the 1 minus p is greater than 0, what will happen? So if 1 minus p is greater than 0, it is divergent. If 1 minus p is less than 0, then p is greater than 1. If p is greater than 1, as I told you, it is u to the power of 1 minus p will be equal to 1 by p u to the power of p minus 1. So if p increases, so if when u tends to infinity, you see that this will be a decreasing one, and it tends to a finite limit, because of which this one, the whole thing becomes a finite one. Hence this integral tends to a finite limit, hence convergent when p is greater than 1. When this is convergent, the subsequent series S is equal to p series is also convergent. So what we conclude is that we conclude that sigma of 1 by n to the power of p, n is equal to 1 to p, when n is equal to 1 to infinity, converges for p less than 1, and diverges for p converges for p greater than 1, and it converges for p less than or equal to 1. So this sigma, so this particular discussion comes using this integral theorem. See, I go use this integral theorem. I use the integral theorem to prove whether for p greater than 1, whether it diverges or converges, and for p less. So for p greater than 1, it is converging. For p less than 1, it diverges. So this is the discussion. So you must understand that when you are doing comparison test, we take this,